Hi all. Okay, so this is a video to help consider the purpose and the analysis of the circular motion / central net force lab. So the question at hand is, what net force is needed to move in a circle? So here we have a stopper, and that stopper is moving in a circle, right? And there's a force sensor, and you should have that force sensor freely read the tension in that string, causing it to go in a circle. As we discussed, for a thing to go in a circle, it needs to be pushed, right? And it always needs to be pushed toward the center of that circle. So it needs to be moving, and it needs to be, while moving, pushed toward the center of a circle, and that's why it'll move in a circle. So the lab's purpose is to describe that net force. And we're going to have a few different variables. We said that the mass affects the net force, and we may presume that the mass affects it positively, so that if the mass increases, the net force would also increase. We said that the speed would likely affect it. I'm going to write V for velocity. As it's moving faster in a circle, it might need a larger force to increase the to cause it to go in that circle. We also suggested that the size of that circle, the radius, would affect the force needed. And as the radius gets larger, if something's moving at a certain speed, it's easier to push it in a circle if that circle is bigger. So if the radius gets larger, then the net force presumably will go down. So you're going to need to collect 3 different data sets, each that relates the net force to each of those 3 variables: mass, velocity, and radius. When you do that, you're going to have some graphs. You may graph your data. Net force in the first one might be versus mass. Some things to expect. I might expect that data to be directly proportional, which would suggest that the net force is equal to something times the mass. Okay? You're going to have another data set, and that other data set will be net force as you increase the speed. Okay? And this data set may look like a parabola, in which case the net force, if we're going to turn it into a straight line graph, we have to do net force versus the speed squared. And that graph will turn into a straight line, indicating that the net force is equal to something times the speed squared, or the velocity of that object squared. And finally, the net force and the radius. So here, if we have the net force and the radius, we suggested that as the radius increases, the net force will decrease. I might expect your data to look of that sort, which is an inverse graph. And to turn that into a straight line, net force times the inverse of radius, 1 over r. That relationship ought to be directly proportional. So net force will equal something. That something is always your slope, times 1 over r. Now let's use these 3 things here that I'm going to underline in black to combine them, right? And we might combine them to get the answer for our lab. The goal of our lab is to indicate what things affect the net force and how do they do so. A great answer would be a mathematical relationship. Here we would suggest that mass times something, and that something might be velocity squared, mass times something, which is 1 over r. So I'm going to divide by r. You can use, in your lab, you can use different slopes. So m over r here should be the slope of your velocity squared graph, right? M times v squared should be the slope of your f net versus 1 over r graph. And v squared over r should be the slope of your FNet versus mass graph. The data that we're going to collect is likely very, very uncertain. So the likelihood that your slopes actually match what they're supposed to is pretty low. But from our data, we can conclude these relationships. The mass is directly proportional to the net force. So our equation just has mass in the numerator. The velocity is proportional to the net force is proportional to the velocity squared. So we have v squared in the numerator of our equation over here. And the net force is proportional to 1 over the radius. So we have radius in our denominator. Your lab is to write an introduction, a method, and a conclusion. The goal is to figure out the effect of certain variables on the net force needed to cause something to go in a circle. Your answer ought to be a written paragraph that cites evidence from a mathematical relationship. Your answer ought to have this net force equation.